Hi, I am Kestridhar, studied in CSC A section. I am explain about Tech Talk. Subject is TWDM. Definition of appropriate algorithm. The appropriate algorithm is a influential algorithm for mining frequency item set for Boolean association rules. Appropriate use a bottom-up approaches where frequent subjects are extended one at time. To speak down is a candidate generation, and groups of candidates are tested against of data. Appropriate is a designed to operation on database containing transactions, for example, collection of items bought by customers or details of a website's frequencies. Key concepts: frequent item set. All the set of has contain the item with the minimum support denoted by Li for ith item set. Appropriate property. Any subset of frequent item set must be frequent. Join operation. To find Lk, a set of candidate k item set is generated by a going Lk minus 1 with itself. Next one is steps of performance on appropriate algorithm. Step 1. Scan be a transaction database together support of as each one item compare S within the support and target support of one item sets L1. Next step is use Lk-1 join Lk-1 to generate a set of candidate k item set and use the appropriate property to pawn to unfrequent k items from the set. Next step 2 is scan the transaction database to get the support S each candidate k items in the find set 1 compare S within the minimum support and get a set of frequent k items set in L2. Next step 4 is the candidate set null S has step 5 no has step 2. Step 5 each frequent item set 1 is generated to all non-empty subsets of an 1. Next step 6 is for every non-empty subset of 1 output the role s equal to greater than less than or equal to 1 plus s star is confidential. C has the rule s is less than or equal to 1 minus s star supported of the 1 supported of s minimum confidence. Next one is appropriate algorithm examples of market database. Market basket analysis provide insight to which product tend to be purchased together and which is an most amenable to promotions. Actionable rules, travel rules. People who buy chalk pieces also be a buster. Next speculations. People who buy mobile also buy bag. Appear algorithm examples. C. Easy to understand. TID items at areas 100, 200, 300, 400. Items as 1, 3, 4, 2, 3, 5, 1, 2, 3, 5, 2, 5. Next step is C1. Item sets. Find the item sets. Item sets is 1, 2, 3, 4, 5. Supports has it has 1 has 2 supports. Next 2 has 3 supports. 3 has 3 supports. 4 has 1 support. 4 5 has 3 supports. He has the least in supports is 1. So we remove the 1. Next box L1. It has remove the support 1 has 4 items at 4 is deleted. Next one is 1 2 3 5. Its supports is 2 3 3. Next box is pair of the item sets 1 3 2 3 2 5 3 3 5. Next supports. See the supports. 1 3 is 2, 2 3 is 2, 2 5 is 3, 3 5 is 2. Next pair is 2 supports 1 2, 1 3, 1 5, 2 5, 2 3, 2. Supports is 1 2, 2 1, 2 1. As 1 1 is least support, so it has deleted. Next one has item sets is 1 2, 1 3, 1 5, 2 5, 2 5, 3 5. Item set next to 3 item set has a 3 steps. 2 3 5 has the item set is 2 3 5 is 2. Next one is the appropriate algorithm pseudocodes. Join the step 1. CK is generated by a joining LK-1 with itself. Prune step. Any K-1 item set that has not frequent cannot be an subset of frequent K item set. Pseudocode K candidate item set of size K. LK frequent item set of size K. L1 frequent items for K equal to 1. LK equal to pi naught K plus plus is begin. C I plus 1 equal to candidates generated by from Li. For each transaction T is the database to increment the count of all candidates in Ci plus 1 that are contained in T. Li plus 1 candidates in Ck plus 1 with minimum support and turn equal to L2. Next is limitations. Appropriate algorithm can be very slow and the bottleneck in the candidate generation. For example, the transaction DB has the 10 power 4 frequent one item set. They will generate 10 power 7 candidate 2 items even after employing the downwards closure to compute those with steps more than the minimum supports. The database need to be scanned at an every level. I needs n plus 1 scans where when n has the length of the longest path. Next are methods of improve the appropriate efficiency. Hash based item set is counting a k item set whose corresponding hashing bucket count bucket count bucket count is below to the iteration threshold counted frequency. Transaction reduction. A transaction that does not contain any frequent k items is useless is subsequent scan. Partitioning. Any item set that proportionally frequent DB must be frequent at least one of the partition of DB. Simply sampling. Meaning of the but subset of given data, lower support threshold, a method to determine the completeness. Dynamic item set counting. A new candidate item set only when all the other subjects are estimated to the frequent. This is my tech talk topic. Thank you.